All right, day 21. We have a numpad and then we have a keypad. So we need to find the shortest path for each input, and then we need to find how you're gonna press the directional keypad to input that, and then you need again to check on the directional keypad how you're gonna press the directional keypad. So we'll start by defining the numpad and the keypad. So I've added CG Math itertool and one cell, and one cell allows us to define static variables lazily. So the numpad is going to be a hash map of characters and vec2. I'm also going to define what a vec2 is. And so this will be lazy new, and then we can define the lambda here. So I can't type today. We should add 7 should be at 0, 0, and then 8 at 1, 0, and 4 at 0, 1. So y goes down and x goes right. So and in the end we're gonna return map. And we have this should be 4, 5, 6, and then 1, 2, 3. And the last row should be 0 at 2, 3, and the A at 1, 3, 2, 3, and these should all be characters. And then we should do the same thing for the directional keypad. So I call the numpad and this the keypad. Same thing here, but we're gonna change this. So we should have up at 1, 0, and then A left, down, right. So up at 1, 0, A at 2, 0, And then we have left at 0, 0. Down, right. Now we need to find the shortest path. We need a function to calculate the shortest path from any character at the numpad to any. So let's say we're going from A to 5. We could either go up, up, left, or we could go left, up, up. It will never be shortest to go up, left, up, because then when you should input that, you need to move it away. It's always more optimal to move in one line, but we don't know if it's better to move up first or left first. If we are moving to 1, 4, or 7 from A or 0, we need to always move up first and then left. Same thing if we're moving from 7, 4, 1, we need to move right first and then down. So we can create a function for that. Get numeric shortest path. So we have a from char and a to char. And this should return a list of strings. And the string could be like up, up, right, for example. Since it could be up and then left, or left and then up. Needs to be a list. So we should get the start position. From. And this needs to be and then we have 2. No, and should call them different things. And then we should know the delta, which is the how much we need to move. So then we should get the characters for moving either horizontal or vertically. So if we're moving right, we should get the right character, and left, we should get the left character. And same for Y. If we're moving down, we should do the down, and up, we should do the up. And we should also get how much we should move in either direction as an absolute unit. And so then we need to check if we're moving from A or 0 or 7, 4, 1. So if from is A or from is 0 and 2 is 7 or 2 is 4 or 2 is 1, we should return just one path, and that would be to move vertically first. So we can repeat vertically. It will create an iterator that just returns this over and over again. And then take Y and then chain that by repeating the horizontal and take X and then correct. Otherwise, if we're doing the other way around, so we're moving from 7 for 1 to A or 0. Oh, right. Need to import that one. Then it's the same thing, except now we should do horizontal first and then vertically Y. Otherwise, if we're only moving in one direction, we should only get one, but if we are moving in both directions, so X is bigger than 0 and Y is bigger than 0, then we should return a list of both these. So this one, oh right, last case, we're only moving in one direction. We can just copy this one. It doesn't matter the order then. So now we have a function that calculates all of the shortest paths from 2. Now we need to do the exact same thing, but for the keypad. So get keypad shortest path, then we should use the keypad here instead. And now if we are moving from A or up to this one, to the left, we have to move vertically first. Otherwise, yeah, from this to either of them. So if we vertically first, that should be if from is up or A, and 2 is no left. Yeah, we're just the rest is the same. Now, in order to save time later, we can calculate all of the shortest paths just once, so we don't have to do it all over again. So we can create numeric shortest path again as a lazy. So it should be a hash map from to, and the value should be a vec of strings. So we can get all of the keys. From the numpad. And then we need to dereference it. Then we should have all of the paths. So that needs to be mutable because we're gonna fill it. And it's not compiling. Hash map char vec string. Right, because let's see, hash map be okay. So all of the paths, we're gonna iterate over the keys and do tuple combinations for each from to, and then paths insert, and then from to get numeric shortest path from to. And then we also need to do in the other way. We go in both directions. And then we can do the same thing. Oops. For keypad. Okay, so now I should get the, we are ready to get the input. And we should start reading it. So let data read to string, unwrap. I always trim it because sometimes I get some weird spaces when I copy. And then the codes will be data lines collect And then we should go through all of the codes and get how many characters we need to print. So let's take the example input of 029A. So we can just let the code be that for now. Yes. So we want to know how, like, this string should give us one of these strings, or all three actually, but we want to know the length of these. Let length be get numpad code length, and then we can send in the code and we can generate this function. So now we want to know the input to get from 0 to 2 and 2 to 9 and 9 to A, but also you start at A, so you want to insert an A in the beginning. So let's have the characters as a list of characters. And this would be code characters collect, and then we can insert at index 0 an A, and then we could move through all of the tuple windows for the characters and then sum the cost. So characters, iterate over them, tuple windows, then map each window, which would be a from to. And so then we should get all of the paths from to to. So paths will be numeric shortest path, and it takes a reference to from to. And so the length, all of these paths are equal length, so the length of the path should be the length of this path, but also you need to press A, so +1, and then you can sum this and return. And so now if we print the length, we get an error. And the reason for that is we have mistakenly done a 0 instead of 9 there. Otherwise this seems correct, but here this is wrong. This should be 1 1 1. Now if we save and run, we get 12. Okay, and so running this gives the length of 12 for this, so we can compare that to this, and it's 12 characters long. So now we actually don't want to return this. Instead, we want to return the key path length for the shortest one of these paths. So we would like to return paths, iterate over it, map the path to the get keypad code length instead, and send in the path. And then we want the min value for this and unwrap. And we haven't created this function, so we'll generate that. Should return a use size. And then again, we want to go from A to the next, so iterate over the tuples. But we also need to end every code input by pressing A, because that is actually pressing the character in the previous, like on the numpad. So we want to get the characters exactly like this. But then we also want to push an A to the end. And again, we want to iterate over this. The tuple windows, map start to, can copy all of this. But now instead we want to get the numeric, the keypad shortest path. And again, the path length should be the length plus A, so plus 1. Right, so so if we run this, why is this complaining? Oh. No entry found for key. So let's print this. Up to up. So if we are moving just from the same place, so up to up, then it should just be 1. So if from is not equal to 2, we should return this, otherwise just return 1 to press A. And so then we get 28. So let's compare that with this. So that is correct. Now we just need to we shouldn't actually return this. We should return calling this function again on all of these paths and get the minimum. So we can introduce a depth variable. So we'll just say that if depth is 1, we'll return this. Otherwise, we should instead call do what we do here. So map the path to the shortest. So I'll just copy this. Here. And so we just then want to return the depth -1. And here we need to provide the depth 2. So now if we run this, we get 68, and we'll test that with this one, 68. All right. Now we can run this on the actual input. So we can say part 1 should be equal to the codes, and we'll iterate over them, and then we'll map each code to, we want the length, that would be get numpad code length for the code, depth 2, and then the numeric, that should be code, and then not get the last A, and then we should parse and unwrap that, and we should return length times the numeric value, and in the end sum this, and we can print part 1. Right, we can include the depth here. And not hard code it. And that should be correct. All right, and that is the correct answer. And then for part 2, we just want the depth of 25 instead. So we'll just copy all of, it's just part 2. And say 25 here instead. So even if we run this in release mode, this will run forever. So we have a recursive function that takes forever. The answer, as it almost always is in this advent of code puzzles, is to use memoization. So we will introduce a memory that caches the value. So hash map, the input should be a string and a usize. The output should be a usize. Then we can create the key. We call it mem key. And that would be the path to string and the depth. And then we'll check if memory contains key, mem key. Then we should return otherwise we'll just say if let result be this, and then we will update the memory, insert mem key result, and then return result. And here we need to include the memory. Here we need to include the memory. We need to add this to this one as well. Here we don't need to cache it. It doesn't make a difference. And now it should be pretty fast. Yes, you could create this outside also. Let's make sure we got the correct value also. It's not correct. Let's see why. And here it is in the get keypad shortest path. It should be, if you go from A or up, you should always start by moving vertically. But if you go from and to A or up, you should move horizontally first. And then we get the correct result. All right, part 1 and 2. Pretty hard problem, I think, at least for me.